I'm a developer here in Thaler. I've been working here for like 2 years ago. I wanted to show you something that I built for a talk. You might know Thaler because he's already been presented here in this kind of events. So, but if you don't, you want to remember that there is an exchange that where we can withdraw money with our wallet that we can install in as a web extension or as a mobile software here as Android. And we can use the wallet to withdraw money and pay to a merchant that has a back office installed. And the merchant can do the deposit of the money. And the feature, the most nice feature that it is completely private, have privacy for the one who uses the wallet. So not even the exchange or the merchant can stop the people for using the money. It is not it is not built using cryptocurrency. It's a digital payment system that is use token-based payment. What I built here is device that use a cache validator, convert the signal to USB serial. And there is a server that listens to this information. So whenever I send money through here, it will say, okay, you have $20 or 20 euros to pick up. And then we can scan it using our web extension or using the mobile device to fill up our wallet with the money. Essentially, what we are trying to do here is like when you go to buy some coins to play in an arcade machine. So after having the money in the wallet, I can scan another QR code that will talk to the payment listener, and it will send the information to the arcade machine to play the game. So we can have this. Let me, for example, show you. This is the arcade Thaler pickup. There is no money yet. I will start it again. So if I reload, there is no money. And then I'm going to insert here some money. It is validating the cache. So if I send some dollars here, it won't read it. I'm going back. So now the server has $20. If I go to this page, it will redirect me to collect the tip. And when I open the wallet, if you see there, it has detected that this page has an Thaler tipping protocol. So when I open the page, the wallet will get the information, and I will be able to accept the tipping from the merchant. Right now, I don't have any balance, but when I accept the tip here, you will see my money in the wallet. After picking up the money, there is no more money here in the server, and then I can go to pay. I can go to pay on a machine. I can scan a QR code or go to the URL. I'm going to show you here through the web extension. I'm going to the arcade Thaler Pay. It's going to show me another QR code to make the payment. And when I use my wallet to pay, it will present all the information to be paid. As you can see, it's really fast. And after paying, it should be running. Oh, I forgot to run the notification. Then start the game. So what I have here is a listen validator that is always watching the money picked up from the machine, and then another service here that is checking the merchant backend where the payment is made. And after the found a complete payment, it runs the game. So that's it. That's the talk. Hope you like it.
Does anyone have any questions at all? So, I've got one. So, with security in the system, with the QR codes, is there any extra security on top of that, or do you have a password to access the wallet? Or
no, the idea here is that the exchange is the one who holds assets or holds the money, and is the one who's printing the coins to the wallet. So when the wallet go to the exchange and ask for the money, the money is already saved into the wallet in the web extension or in my phone. So it's more like cash. It's not that you have an account somewhere and you need your password or your account to save your money there.
So if your phone died, would your money die?
Yes, exactly. You have a backup. That's why we have this feature here to do backup of your wallet. And yes, definitely, if you lose your money in the real world, you also lose if you lose your wallet in the real world, you also lose your money.
True.
So,
and you gave the example of an arcade. Has it been used in that scenario, or what scenarios has it really been used
well,
in?
this is recently built just like 2 weeks ago. So,
right.
But that's the idea. That's the idea. You can use it in the arcade system, and as you saw, it's really fast. So there is no long transaction delay or long transaction cost because it's a service running in a server and nothing more. There is no proof of work or proof of anything.
What made you design the system? What was your thinking when you invented it?
What I was thinking, using like this, like fast payments.
What made you come up with it? Just the speed? Was that the idea?
Yeah, it's just a demonstration. Okay.
All right, thanks. Sorry, anyone else got any questions or anything? It's, was there a follow-on part for the talk? Yeah. So part 2. It's, this is. So you're both on the same project, is that right?
No, not well. Yes, also, but not this time.
Ah,
Not for
okay.
this talk.
So you're friends, you know each other?
Yes.
Ah, okay, fine, cool. Sorry. Thanks, so we'll just do a quick changeover. I meant to ask, actually, those money detection machines, can you hack those? Are there ways to get around those where you think you've got 20 years and you haven't? Well, how do they work, actually?
What?
How do those actually work, detecting the money?
Well, it has
The cash machines?
Yes.
It should be on. It's on. It's on. Doesn't seem to be.
Oh, it'll probably turn off from the back. That's, it's green light, isn't it? Yeah. So, what's your name? Sorry.
Christian.
Christian. Okay, fine, great.
Thank you for that.
Oh, that's coming up. So that's all at the top of the screen. So you're set. Great. Right, so we'll pass on to Christian to tell us more on the same related subjects. So take it away. Thanks. Wait for the speaker. Can we turn the microphone on at the back, or for the front?
Okay. Well, the last question we had was, okay, what if you lose your wallet? And then his answer was, you have a backup, right? And then the next question is, well, if you have a backup, how do you encrypt your backup, right? And then the next question is, okay, yeah, encrypt your backup with a key, and what if you lose your key? All right, that's my talk. So, and I'm going to give you a demonstration of GNU Anastasis, which is a, well, rather new GNU package. And so this is the idea. You start by, identifying yourself. And before you can identify yourself, you have to tell me who you are, where you live, because we're going to ask yourself a bunch of very personal questions, because this is a privacy project. I know. It doesn't make sense, right? Well, the personal information we ask you for is going to stay on your computer, and we're going to use this to derive an identity and encrypt information with it. Not the main information, but some information. Now, for this demonstration, I'm going to live in Testland. Well, whatever, my name is going to be Max or something like that. And in Testland, well, usually we would ask for your social security number, your taxpayer identification number, stuff like that. In Testland, we're going to ask for your prime number, 2, because it's an odd one, and your square number. I pick 1. Is that okay? So again, think of this being high entropy information that not everybody has, because we kind of have two adversary models, one that knows stuff about you and one who doesn't. And the adversary who doesn't know all of this information about you has no chance of getting anything. Anyway, so the next step is making sure, okay, we don't forget this, I am sure, is to configure authentication methods. And so you can pick the usual ones, send me an SMS with a PIN code, send me an email, use TOTP. Is this your phone? Does it have TOTP readers on it? Well, I can't unlock it anyway. He trusts me very well. He left his phone. And you can also send physical mail, but I'm going to stick to security questions simply because the rest is a bit more involved. And I'm going to have very simple security questions here, you know, first question, first answer. Don't use those. Now the system requires me to put in multiple factors for authentication, but I can do the same ones multiple times, so I'm going to be again very creative, Q2, A2, right? And maybe do a third one for good measure. Yeah, I really can't type with this microphone in my hand, so I'm going to keep it very short. Okay, so 3 top security questions I recommend highly. The next thing is the system will distribute your key shares across multiple providers. And now here you can kind of configure your recovery policy. So by default, if you put in 3, it suggests 2 out of 3. But you can also say, no, I want all 3, or 1 out of 3. And you can also specify at which providers they're going to be stored. In this case, the providers I've got running for the demonstration purposes are the data loss incorporations. Again, in practice, we have actual providers that run this system in various locations, in various jurisdictions. I'm happy with this default policy for now. Now I can name my secret, whatever, MCH. What is the good secret for MCH? I don't know, 2022, not very creative, okay. And now I've made my backup. And again, the different companies have stored different shares of the secret, right? None of them has access to everything. And they are additionally encrypted with information derived by my identity, which also serves like an account identifier. Now, if I go and say I've forgotten what year it is, I can recover the secret. Again, I have to say where I am, because I didn't restart the application, it has remembered at least this form. Otherwise, you have to re-enter it, of course. Now you can get a list of all the things you've backed up at all of these providers. It basically went already in the background and asked all of these providers, hey, do you have backups for this user identity? Right? I can pick, based on the secret name, only have one here, which one to recover. Now I have to solve the security puzzles, and it basically tells me, well, we've got 3 policies, solve one of them. So, for example, I could say, okay, I can solve this one, A1. And now I've solved parts for these 2 policies. Or I could solve Q3, A2. Oh, that was wrong, right? Now, if I do this too many times, it actually locks me out. Correct answer was A3. And it has reassembled the secret, 2022. So, multi-party backup, the providers learn very little. Effectively, only actually things like your email address, your SMS number during recovery, with free software available from GNU. Thank you.
Does anyone have any questions there? So, yes, we do have some. So, right.
So how does that work with like phones and mail recovery? Is it like external party? From phone and email and maybe snail mail, is there an external party that you need to rely on?
Yeah, all of the key shares are always stored at a provider, and that provider will send you the email or the SMS. We also have another method implemented where you have to send me money. That's the business model. You authenticate by being able to send from your bank account to me, €1, then I believe it's you, with the right wire subject. But of course, you rely on email providers or phone system, right? But in the case of security question or TOTP, of course, not really.
What kind of encryption is used at these data providers?
There's multiple layers of symmetric encryption. The first one is basically use your user identity to encrypt both the key share that you have, which again is itself used to encrypt part of the key that is actually the secret that's actually stored. Then we have another layer around it which encrypts the authentication information so that only becomes available during recovery for the provider. But it's mostly AES GCM encryption, symmetric encryption. We use, of course, I think it's the scrypt, so PBKDF hash function to make it more expensive, and we hash the user attributes. But there's no asymmetric encryption required here. The only asymmetric part is we sign the uploads, so that if you upload multiple secrets, we know it's coming from the right account, so to speak.
Somebody,
That answer your question?
Somebody have a question over here.
I was wondering, do each of these data providers have the same data?
Do each of these data providers have the same data? No, they all have completely different data. Each provider has a public salt, and so we even make sure that when we re-identify the accounts look different at the different providers, and they have different key shares, so of course also the things that they're storing is completely different. But they can't even say tell that they're serving the same user, except if they log IP addresses and say, oh, it's the same guy who's coming from the same address.
I have a question too. Could you technically design the encryption in a way so that the password is never known by the provider and just you use the answer as the decryption key, and if the output has the right format, then technically the provider would never have to know the answer?
He doesn't. So what we do all of this. So in fact, the password is hashed in two ways. One is used to also decrypt the decryption key locally, and the provider doesn't learn that. And the other one is the password is hashed with a strong salt, so it's against brute forcing, and then that hashed with a strong salt hash is sent to the provider. So the provider never learns the actual passphrase. But good question.
I actually have a question that goes in the same direction. Is there just simply a white paper detailing all that linked?
There is a bachelor's thesis detailing all of that, which won the Information Security Society Award of Switzerland in 2021. So bachelor's thesis, not a white paper.
Okay, thank you. And how you defined it?
You would find the bachelor's thesis in the Git repository and on anastasis.lu. It should be linked somewhere.
Okay, hopefully I find it. Thanks.
Check afterwards. So, cool. Okay. Did somebody have a question on this side? Or has that been answered? Oh, yes, here we are.
So currently you have about 6 providers where to store the information, or?
Currently we have 3 providers in operation. A 4th provider is I'm setting it up, but taking some time. We have 6 different authentication methods implemented, 5 of which are operation. The 6th one is waiting for the bank to give us the account details so we can actually do the bank authentication. It works in a test setup, but not in production yet, the 6th authentication method. But we have currently 3 providers. If you're interested in running another one, please contact me.
What about a blockchain like Bitcoin?
What? What? A blockchain? Why would you need a blockchain for this?
Well, it's all about storing data somewhere, right? I want
No, because you don't want the data to be necessarily public. Now, in our case, if the provider were compromised and the provider's database finds itself on the internet, you're still in luck because he's only having key shares, right? And it's additionally encrypted. But you still don't want this data to be public, because if I compromise enough providers, which hopefully is difficult enough because there are enough of them and they're around the planet, and maybe they don't know everything about me, but basically I can bypass the authentication if I compromise the provider. So this data should not be public that's stored at the providers.
So you are dependent on the provider adhering to some form of security. You're banking on that.
We are adhering to a sufficient subset of the providers being both available and not disclosing their information.
Thank you.
Against a strong adversary who knows your name, your social security number, and the other information on the first screen.
Clear, thank you.
So if a few providers fail, is there a risk that the system loses your passwords?
Well, the system doesn't have your password, so it can't lose your passwords. But it might lose your stored secrets but it depends on your policy, right? If you decided any one of the providers is enough, then only one provider needs to survive. If you said, I've distributed to 3 providers and I need information from all 3, then one of them failing and you're done. But it's freely configurable.
Actually, I think I just answered my question. I was going to ask if it made any sense to have anything air gapped at the providers, but I guess the answer is no. They can just use a data diode or something internally.
Yeah, I think as a provider, you probably want to also serve the customers when they are really in urgent need for the data quickly, and I don't think there's an air gap need here, no.
I noticed there was an expiry date on some of the secrets. Why would you want that?
There's an expiry date mostly because the providers might not want to commit to storing things forever. And we actually have built the Thaler system as a payment system into it, so the providers could ask for your money to store stuff. And if you promise to store stuff forever, well, the price would have to be infinite, right? But if you say, I'm going to store your key shares for 5 years, you can calculate how much it's going to cost. Of course, you'll be wrong with the inflation, but at least you have a chance of making a business of running the service. And at the same time, I also go and say, well, we don't have a deletion capability. Because we said, well, if somebody could delete my key shares, that might also be just as bad as keeping them, right? So, but having an expiration where we tell the user upfront, this will be kept for 5 years, and then you might want to do a re-upload. And partially, you might not have the same phone number, you might not have the same physical address, so your authentication methods might change. So it's a good thing to tell users, don't do the backup once and forget about it for the rest of your life.
The providers of holding the secrets, if one goes out of business or goes bust, is it like a RAID system where you can reallocate that to another one? Does that rebuild elsewhere automatically?
If the provider is willing to hand over his database to another operator, then it would be possible.
If one was compromised, or
if
you can't.
Again, compromise has two different ways. If he loses the data, then you can't hand it over to somebody else, right? If the data is public, well, you can keep operating and give it to the legitimate users, and you just have to hope that not enough are compromised for your actual secrets to become known.
And is the system in full production now? Is it something that people can use, or is it just in development right now?
We believe it can be used, but we're in the test phase because we're still playing around with the user attributes we're collecting for different countries, the validations, and getting some, let's say, initial production experience. So we don't recommend using it production, we recommend trying it out and telling us what's wrong.
So people can sign up, try it, be beta testers.
It already works. We have also a web user interface that you can use. We have the GTK user interface, so it works. But it just works, right? As in, we've just made it work. And so maybe let's not do the $5 billion Bitcoin wallet in this tomorrow, as the only way of keeping it secret. I would be a bit worried. Right? But you can use it, and there are not really any significant known bugs.
Okay, cool, great. Thank you very much, everyone. So, well, thank you for the talk. So with the lightning talks, we only had the one or the two talks today. So does anyone fancy doing another talk, or should I pick on someone randomly to do a talk? Ah, you fancy doing a talk? Super, why not? Hey, cool. Cool. What? Oh, is that one on? Is the microphone on?
Is this on?
Can we turn it back on again? So, yeah.
My name is Jeff Burgess.
Sorry. I don't. Can we have the microphone on, please? Try it.
Oh, it's working. Okay. Yeah. My name is Jeff Burgess. I work on various things. I actually have worked on Thaler before. That's why I came and found them. But so there's a so Thaler uses these blind signatures. This is the thing that you're hearing about. Is so the person who signs the thing doesn't know what they're signing, which is an interesting prop, which is a useful thing. And there's a number of things. Well, maybe I don't want to run off in that direction, but there's a number of things that people have done with blind signatures where you can sort of issue them once and then redeem them many times. Things like this. So what I want to tell you about is an interesting construction that we came up with for doing things at my current job. It's what we're calling a ring VRF. So a VRF stands for verifiable random function. It's people here kind of know what a hash function does or what a MAC is. So it's like it's a function that we believe it's kind of a random function, and you have like a key to it, and when you put something into the function, then the thing that pops out the other side looks fairly random. And this key defines which function from this family of functions you're taking. Okay. So that's a symmetric cryptographic construction, and you can have an asymmetric one where this is a public key system. So what this means is that if it's my function, if I know the secret, then I can evaluate the function and nobody else can. But also there's a signature-like component, which means I can sign that I can produce a signature that proves a particular evaluation of this function, and it doesn't leak anything about any other evaluations. Okay, kind of a interesting kind of construction. We use them a lot in they're used a lot in certain kinds of distributed systems. Fancy new blockchains, proof of stake things. They're also used in, they should be being used in DNSSEC, but they're not yet. It's been around for a while, that proposal. Anyway, okay, so this thing is, these guys are signatures. You sign something with them. There's also another kind of signature called a ring signature, which is that I have a set of people, and I just prove that one of the guys in the set signed. And there's a bunch of different types of ring signatures, really, really lots of them. But one of them, people here have probably heard of Zcash. So Zcash is a kind of a funky ring signature where the ring is all of the keys that have appeared in the chain in the past. That's a way to think about it. And so it has this way, it keeps growing this ring, and then when you sign with one of these UTXO keys, you can spend the money. Okay. So what we needed for something was we needed this ring VRF for a certain protocol we were building. And so what is it? It's just a ring signature that's also a VRF. So you sign, so each real key defines some pseudo-random function. And there's a ring, which we can keep growing, and you can sign something with it, with one of the keys with one of these keys in the ring. And what that does is that it just proves that one of the functions this is an evaluation of one of the functions in the ring. Pretty handy. Okay, so where did the idea for this thing came from? It actually came from from a guy at APA. I'm the first person who came up with the term ring VRF, but it came from some work by Brian. The idea for doing this came from some work by Brian Ford at EPFL, which basically he wants to have an identity system where you have IDs that are issued either, well, he wants to do it in a very anarchist way, but you could also have them just be government issued. So you have these IDs that are, say, government issued, and what you do is when you swipe, you tap your card on something, it evaluates this pseudo-random function, and it proves to the thing where you're tapping your card that you've evaluated this function correctly. Now, okay, what's that useful for? Well, it means I have a very ephemeral ID. I can say, look, my identity for getting into this club today is this. Or look, my identity on your particular website, I put in Twitter into the random function, and my ID that pops out the other side is my identity on Twitter. So what this proves is that there's only one me on Twitter, or there's only one me going into this club today, or whatever. So there's another thing that's very useful that you can do with this, that is identity. You can use it for rationing. So if in France right now, we have a mustard shortage. We're about to have a lot of fuel shortages in Europe. You can literally have an EU ration card, which would say, here, look, I'm an EU resident. I want to buy this thing today, and here's my right to buy mustard today. And you can do it you can do it by month, you can do it a number of times in a day, whatever, they're all unlinkable. Anyway, there's a variety of nifty tricks you can play with this primitive. Another trick you can play with, a lot of these VRF protocols can be represented as games. You can also play Cards Against Humanity, but that's in a decentralized way, but that's another thing I'll talk about another time.
So we got some questions.
I have just a short question. You said that you can, with the hash, definitely prove that someone, or you can authenticate them as themselves. But isn't it technically possible? I mean, it doesn't fit for the analogy, but that a hash collision could cause two people appearing like the same person?
Yeah. Well, this is these hashes are large, so.
Yeah.
So there are 256 bits, but the elliptic curve only really has 128 bits of security. If somebody wanted to create a collision by designing their keys, they could do it, but you can't really do with only 128 bits of security, but you can't really break that. So you can't, even if you wanted to have really different keys that collided, you can't.
Oh, I've got a question over here as well.
Hi, can you just talk a bit about the R in VRF, like verifiable randomness? Like, can you talk about an application where that randomness is important and where it comes from?
So a lot of times when we're using, like in a cryptographic protocol, when we're describing a hash function, we use what's called a PRF, which stands for pseudorandom function. And the definition is basically that we have a family of functions, and we imagine that we're picking one at random, and then we make certain statements about this. Okay. A VRF is a signature that, I mean, there's a formal definition I can drag out, but it's a signature that essentially, it has these pseudo-randomness properties, and it also has this fact that the public key uniquely determines which PRF is running, or which element of the pseudo-random function family is being picked, and that and then the signature part is you're proving the evaluation of this function. Did that make sense?
Yeah, but where do you get the randomness from? Like, can the person you're proving...
The randomness always has to be coming, there always has to be something in the, well, really the randomness is coming from the key, but which is picking which function in this family of random functions. But sorry for trying to sway into cryptographic language a bit, but really the real randomness is the key. So which is why I can do something like Twitter, on the 14th of July as my input and claim that the output that comes out is random, is because the key is really the source of the randomness. However, there are a number of applications, including this Cards Against Humanity thing that I was talking about, where that's not enough. You also need the so for the identity application, that's enough. There's a number of other applications where you need the randomness. You actually need some randomness coming in on the things. So in particular, if you wanted to, anytime where you're afraid of the users picking their key to brute force something, then you need the input to be random and you need it to be made up afterwards. And so for example, if you've paid any attention to proof of stake blockchains, Ouroboros Praos uses that. And they have to have the randomness that goes to the input to the thing come after all of the keys said, hey, we're staking.
Got it. Thanks.
I've got a question again. So do you see mainstream password managers embodying some of this technology over time?
So, the VRFs. There's a lot of the PAKE app. If you've heard of these PAKE, like password authenticated key. So the thing I'm talking about wouldn't really be for password managers. I haven't thought about that. When you talk about PAKE systems, which is like password authenticated key exchanges, they tend to use a primitive that is somewhat similar to this, but a little bit different.
Great, thanks. So we've got a couple of announcements. So.
Yeah. Thank you very much. And that's certainly well deserved. Hi, I'm Toralf. I'm one of the guys who are actually running the Lightning Talks. And we are actually looking for speakers. So if you've got a topic that you think that's interesting, you've got unfinished research that you want to share or talk about, think about it. Getting up here is not really difficult. You can, or you don't have to have slides, so just get up here and talk. I don't have any slides with the name, just Google Lightning Talks MCH, you'll find the page where you can submit all the information. Or you can find me or some of the other people around the Geraffel village. Thank you.
Yeah. So I was asked to do the ending of this. I'm the co-herald of him. So I have a few things to ask you. First of all, is to drink a lot of water, but I think he told you that already. The second thing is, please consider becoming an angel. Like we two are angels. We're doing this right now. And any angel who does a shift can get an angel shirt. That's not an angel shirt, as you can probably see. And angels who do parking or trash, they will get a patch. It's probably not that well visible. That's the trash angel patch. And there is an angel for parking. They also get their patch. And you can keep it afterwards, and it's just a nice memento. And I have another little thing. All scattered over the camping field are field phones. These are the ones with the hand cranks. Just feel free to use them. We can connect you to anyone on the field if you give us the deck number, or we can connect you to the info desk or anywhere else. So have a nice day and be nice to each other.